Let's look at pressure independent control valves. Now, we can talk products, but basically a pressure independent control valve is one that limits the flow like a flow limiter to whatever you got it set on. Plus, it keeps a constant differential pressure across the two-way valve. Kind of like having two valves in one. It keeps a constant differential pressure across the two-way valve. So now if you know the position of the valve, you know the flow. The two-way valve sees a constant differential pressure. That's critical. Here's an animal or a product that we sell that you can actually read the flow in GPM and set it. That's a pretty neat idea. You can actually dial in the flow you want in GPM. Run a little red dial there. You can dial the GPM in. It's plus or minus 5% accuracy. And you've got full stroke available to you. Great concept. So the point of a pressure independent control valve is to be able to make sure you limit the flow and you keep the delta T up at partial loads. That's the advantage of a pressure independent control valve. So let's get away from the product a little bit and get over to what we're trying to do. Here's a typical ARI certified cooling coil. And real quick, this coil was picked for 12-degree delta T at 100% load, which is the vertical axis on the left, at 100% flow, which is the horizontal axis on the bottom. So if I go to 100% chill water flow, go straight up to the solid black line, you'll see to the left 100% load, and the solid black line is 12-degree delta T. Great. That's what you expect. That's what you design. That's what your chiller plant was picked on. That's a delta T required. That's how you keep the return chill water temperatures up. That's how all these good things are going to happen to you if I can hold at 12 degrees. Now, ARI goes a step further. We don't normally run cooling coils 100% load. I would say 50% load would be where we normally are. So with 50% load, let's assume we'd have 50% chill water flow. Let's just take a look at half flow. Let's look at half flow in GPM through a typical ARI certified cooling coil. See what we would predict would happen to the ability to cool. Let's see what we would predict would happen to the delta T. So in this case, if you went to 50% design flow and you go straight up, where are you coming out? Let's just see. We go straight up at 50%. Looks to me like we're running in the neighborhood of 75 to 80% cooling. Take the 50% straight vertical line up to the black line. The black line is the coil line. To the left, I'm seeing about 80% cooling. Wow. At half flow, in theory, I'm going to get 80% cooling. What delta T? A delta T is colored. The 12-degree delta T is that kind of a bluish line, I guess, green line. The purple or pink line at the top is the delta T would be at 50%. So 50% flow, the pink line crosses the black line right about 50%. That pink line is 19-degree delta T. ARI is telling you as you reduce flow in cooling coil, your delta T should go up. Why in the real world why is that not happening? Why? Why are we not getting a higher delta T across two-way valves and cooling coils apart flow? Here's the reason. You're getting unavoidable pressure variations in a system. Differential pressures across the two-way valves are jumping up and down in great big systems. Not by huge numbers, but 5 or 10 pounds. And they're changing instantaneously. Open and close valves, you turn pumps on and off, somebody's changing T-stats. There always has these differential pressure fluctuations. What does that do to you? Here's some charts. I gave you one on building one. Here's another building. And you see that varying 10 to 15 pounds easily, very quickly across the valves. What does that mean to you? If you have a two-way valve and you vary the differential pressure across it, the load's not changing instantly, but the flow is. And we'll show you a chart of that in just a few minutes. How would a pressure independent control valve help you out there? Very simple. A pressure independent control valve is two pieces. This is a typical pressure independent control valve you're looking at. The left-hand side is your two-way valve. P1, P2 is going to stay constant. How in the world can P1, P2 stay constant? Because P1 to P3, the pressure independent control valve is spring-loaded. It's going to make sure that differential pressure stays the same. The second part of this, the spring part of this part, is going to make sure the differential pressure from P1 to P2 across your two-way valve stays constant always. Pretty neat trick, but that's what they do for a living. And what does that mean to you? Here's a central chill water plant, say a cooling coil, and you got direct return piping. And you got to pick the two-way valves. Let's say it's a long campus run. So we got cooling coils two-way valves in close to the big pump. This is my chill water distribution pump. Pretty high head pump. What is it? You see the differential pressure, pretty high differential pressure in close to the chill plant. Now, as you move out further and further away to the end, the differential pressure obviously goes down as I move, 500 feet, 1,000 feet out in the pipe. To the last coil out there, there's very little differential pressure left, and all you got is a two-way valve and the coil. So what happens in most cases is these two-way valves are always pretty much pick the same valve authority. Should not be, but they pretty much are. The same valve authority in close as out to the end. And if you do that, the same valve authority to one way out to the end, and the same valve authority for the valves in close to the chiller plant, the valves in close to the chiller plant become just on-off valves. They don't even modulate. Pop up a little bit, probably going to eat them up. In other words, you're losing control of those valves. You have very little valve stroke. You're going to lose delta T control on them. They're going to have a tendency to take more water flow than designed. You should be picking these valves on what? Every two-way valve here should be picked on CV. Every two-way valve here should be picked on authority and pressure drop available. You should run a detailed head loss calculation on every circuit on that campus for 1,000 valves and make the right valve authority and the right CV every two-way valve on that campus. That's not quite practical, you said. I'd agree with you, it's not. But you can do it. In theory, you can do that. But every time you change out a valve on the campus, you got to look at all the other 1,000 valves that are still there and make sure they got the right pressure drop. Putting all this together is two-way valves properly picked should be picked on valve authority, rangeability, and CV every time. And the ones closest to the chill water plant have to have a much higher valve authority, much bigger pressure drop across them to make them open and close properly. Hard to do, not impossible, theoretically possible, but kind of hard to do in the real world. So that's why we want to look at pressure-independent control valves. Let's see if we can get this message across to you. Here's a two-way valve. Let's say this system is a 500 GPM coil. I got a good two-way valve in here. Inlet pressure is 26 feet. Outlet pressure is 16 feet. I got a valve set for 280 GPM, conventional everyday two-way valve. What happens to the flow rate through this coil and through this two-way valve if I increase the differential pressure? I'm not going to change the position of the valve. I'm going to hold the valve position right where it is. I'm just going to increase that 26 feet to 36 feet. Still got 16 coming out. I got 10 feet of head across at 280 GPM. I'm going to double the available head, 36 to 16 to 20 feet. I'm not going to change the position of the two-way valve. I'm not going to change the load on the coil. This is instantaneous as this pressure drop changes across the valve that goes on big systems every day. What happens to the flow rate? The flow rate jumps from 280 to 400 GPM. Jumps up. Did the cooling coil load change? Not quickly. It's just instantaneous. So instead of having a high delta T, you got the same BTUs at 280 that you got at 400 GPM. If it's the same load and you increase your flow rate from 280 to 400, what's your delta T got to do? It's got to come down. Q is equal to GPM times 500 times delta T. Then when you have that coming down like that, your delta T has got to come down. You've lost control. You got a chill water plant. You got to return chill water temperature problem. You can't load your chillers up. It's an energy hog. In other words, you're losing delta T because you have a standard two-way valve. You don't have the ability to react that quick. What happens if I put a pressure-independent control valve in to the same situation? Now I changed the valve to a pressure-independent control valve. I got 10 feet of drop, 26 in, 16 out, 10 feet, 280 GPM. Great. What happens to a pressure-independent control valve if I double the pressure drop across it? If I go from 36 feet to 16 feet, what happens to my flow? I'm not changing the position of the valve now. I'm not going to change the position of the valve. Pressure-independent control valve with the spring load will pick up on that differential pressure increase instantaneously and hold it to 280. So now I have the ability with a constant change in differential pressure to hold my delta T. I can get the higher delta. I can get my return chill water temperatures up. I can get my return hot water temperatures down. Yeah, you want to do two separate things there, but it's the same thing. You want the highest delta T's you can get. In order to get them, pressure-independent control valves will do it for you. And one of my pet peeves is I got people out believing you can put a two-way valve in series with a flow limiter and do the same thing. By the way, before I leave this slide, you would, in theory, no longer need a balancing valve, because now you can look at the position of the two-way valve. And the particular PIC valves we have GPM on the dial. You can actually read the GPM on the dial of a Bell&Gossett PIC valve. But where we are right now, we no longer need a balancing valve if you could do that. Let's take a look at this again. As long as I stay, just like a flow limiter, within that straight line, minimum pressure required to make it work at 5 pounds, in this case the max is 70, as long as I stay in that range across my two-way PIC control valve, I'm going to maintain flow rate. I'm going to give you the highest possible delta T. I'm going to give you the highest possible efficient system with a pressure independent control valve. Like I said, one of my pet peeves, I have people telling me, you just put a two-way valve in series with a flow limiter. You can do the same thing. Let's just make sure you understand that's an outright lie. It's just not true. It's not true. Why is it not true? I've got my situation. This is a 500 GPM coil. 500 GPM coil. So if you got a 500 GPM coil, at what flow rate do you have to pick your flow limiter? 500. So I put a 500 GPM flow limiter in series with my two-way valve. I got the same setup as before, standard two-way valve. I got a flow limiter picked for 500, but I'm running at 280 GPM. My two-way valve is partially closed. I got a partial load. I got 10 feet of drop and running at 280 GPM. Everybody's happy. What happens if this differential pressure thing changes again to 20 feet like we did in the previous example? The two-way valve is going to jump up to 400 GPM again. I'm going to lose delta T control because why? Because that PIC valve is not here. You got a regular two-way calibrated valve. What is the flow limiter doing at 400 GPM that you picked for 500? Nothing. There's not enough differential pressure across the spring to make it work. It's sitting there deaf, dumb, and happy, just sitting there. That flow limiter is not going to do anything until you get to 500 GPM. That automatic balancing valve is not even going to start functioning until you get to 500 GPM. So now I've jumped from 280 to 400. Load didn't change. Differential pressure changed. I lost delta T control. So, two-way valve in series with an automatic balance and a flow limiter is not the same thing as a PIC valve. That's a lie. Do not accept that. Do not accept that it's the same thing. It is not. Pressure independent control valves would keep your delta T up. This would help with the total flow. It will never be over 500 GPM. That's all it's going to do for you. So enough said on the PIC valve. You kind of got the concept how it works. The idea is that spring load is going to maintain a constant differential across the two-way valve, P1, P2. You can now pick your pressure independent control valves on GPM. You don't even have to worry about CV. You can now pick, that's right, you can pick your control valves now just on gallons per minute. What GPM is it? What valve do I need? You don't worry about valve authority. The pressure independent control valve will take care of that for you. So I'll start tying all this stuff together a little bit. What can pressure independent control valves do for my system? And I kind of jumped ahead a little bit of myself, but basically between 5 pounds and 70 pounds, I'm going to keep a constant flow no matter what the differential pressure does. My control valve's going to stay in the same position. I'm going to get your delta T's up. This is a product we have. Don't want to go through it too much right here, but the basic idea is we give you full stroke, no matter what the setting. You can set the total flow limit on these animals, and they read in GPM. Great benefits. We kind of went through the whole issue. I don't want to bore you too much. You can read them right here, but we can maintain constant flow as I change differential pressure transducer. As I change the differential pressure, I can prevent valve hunting. I can reduce power and energy costs because I'm giving you a high delta T. I increase the efficiencies of the boilers and the chillers as I increase your delta T. I don't worry about valve authority, really. The pressure independent control valve takes it. I can just pick them on GPM. You can set the max flow through them. It takes in effect all those differential pressure things going on in my system and just neutralizes, so I don't have to worry about them. Bottom line, you can pick them on GPM. You don't have to worry about CDs of the valve so much.